Hello students, how are you? So we will continue the same coordinate system in coordinate geometry in the succession of the previous class where we have discussed about the formula for the centroid and the in center. Today in this session we will be getting we will be actually finding the formula for the orthocenter and the circumcenter. And next after that we will also discuss about the shifting of origin and transformation of axis, and then after we will do the slopes. Slopes already we have discussed the basics of slopes, but today we will talk about the angle between two lines, so through slopes. So if we know the slopes of two straight line, we can actually find the angle between two straight lines. And then I will also discuss some locus if the time permits, otherwise we will see in the next class. So let's start coordinate system. Okay, so coordinate system. In this, here see ABC. ABC is a triangle and the coordinate of A is x1 comma y1, coordinate of B is x2 comma y2, and the coordinate of x3 C is x3 comma y3. O is the circumcenter. Let O be the circumcenter here. So you know very well, if O is the circumcenter, so OA is equal to OB and that is equal to OC. Okay, so here this is OC and all are equal to R. R is circumradius. What we have to find? We have to find the coordinates of the circumcenter. Find the coordinates of the circumcenter. So circumcenter is O here. So we do some construction. First of all, we will join O and on BC, let it be joining here E. So OE. And make a perpendicular here. This perpendicular is OD. Okay. So we have OD is perpendicular on BC and AE is the straight line. That is the part of basically this is the line, and this line is here E point is on BC and OD is perpendicular on BC. So what we have to find? We have to find the coordinate of the circumcenter. Okay. So we will see here we have this straight line. One basic formula that we are going to prove it here. What would be this angle? This angle will be 2 times of B. This angle will be 2 times of C, and this angle will be 2 times of A. So this will be A and this will be A. How? I will prove this. This is a circle. This is the center So angle made at the center is 2 times the angle made at the circumference taking the same arc. Let's say A and B are the 2 points on the circle, and if you draw an angle, that's angle is APB, APB. So angle APB is half of angle AOB. This is the basic Euclidean geometry theorem that you must have done in 10th grade. The angle made at the center is double of the angle made at the circle basically, and using the same arc. If the 2 points end points of A and B, these two are joined at P, then this angle is half of the angle made at the center. This is the rule. So what do you mean by this? This is, we are talking about the circumcenter. So this, a circle must pass through all the vertices of this triangle. Yes or no? That's why this is known as circumcenter. O is circumcenter. So angle made, what is the angle here? This angle is nothing but B. So this angle will be 2 times of B, yes or no? Because O is the center. In a similar way, this angle is C. So this angle will be how much? 2 times of 2C. This angle is A. So 2 times of this is 2A. Now what I did here, now the second, see here, if there is a circle, okay, and this is the center, and here BC considered as a chord. BC is nothing but the chord of the circle. So if you draw a perpendicular from center to the chord, here it is OD, then it is divided into 2 equal halves. If you join, these two are nothing but these two are the radius, circumradius. Not in this triangle, but in the bigger triangle I am talking about. So this radius both are equal. This is equal. This is making an angle of 90 degree. So both the triangles are congruent. So it means by CPCT, all the parts of the triangle, corresponding parts will be equal. So this angle will also be equal to this angle. So what is the total? This angle is 2 times of A. As you see, this is angle A. So it would be how much? 2 times of A. So this OD will divide into 2 equal halves. This will be A and this will also be A. Is that clear? So now moving to the next part here. So I have made you understand that two basic geometrical concepts. First is the angle made at the center with the same arc is double than the angle made at the circle basically. At the center is 2 times than the circle, first thing. Second thing is that if you draw a perpendicular from center on the chord, so chord is divided into 2 equal halves, right? So now again see this. This is A, this is a B, and this is C. This is your O, that is circumcenter. I have joined this. Okay, this is O, let it be O. So one is this, that is OE, and another is making a perpendicular OD. Now, as I told you, this angle is A and this angle is also A. Is that clear? What would be this angle? This angle will be 2C. And what would be this angle? This angle will be 2B. You have the coordinates x1 comma y1, x2 comma y2 and x3 comma y3. Clear? We are using the two concepts. What are the concepts? This is the line. BC. I am just taking the small portion of this BC. The coordinate of B is x2 comma y2 and the coordinate of C is x3 comma y3. Now here there is a point E. E is lying on the side BC. We need to get the coordinate of E. How will we get the coordinate of E? If we know BE upon CE, if we find BE upon CE, then we will get, with the section formula, we can get the coordinate of E. Yes, that is the first part of this. Step 1 you can say. What is step 1? Like if we somehow getting BE upon CE, then it will be easy for us because we get the ratio, and this is how we can apply in section formula and we can get the coordinate of C. That is the first part. Second part is, now see, A, add here E, and this is O. AO is already given, that is the circumradius. If somehow we are getting OE, I mean AO upon OE, if we are getting somehow, then also then we will get the coordinate of O, because we will get the ratio AO upon OE, wherein AO is already given R, and OE, if we are going to find it, then we will find the ratio, and with the help of ratio we can use the section formula and we can get the coordinate of O, that is the circumcenter, and that's what we are required in this question. But for this we need the coordinate of E, and coordinate of E we will get in the first step. After getting the coordinate of E, we will put here, and then again we will try to get the OE, and once we get OE, then AO upon OE, this relation we will be establishing, and then finally this, and we will get the coordinate of O. Okay, so now the question is how to get BE upon CE. That is the very first part, BE upon CE. For this we have to see in multiple steps. So let me rub this part first. Okay, so now see here, we have to find BE upon CE. Is that okay? So can we write here half times, here it is OD into BE upon half times OD into CE. Can we write? Yes or no? In this, half and half get cancelled, OD and OD get cancelled, we are left with the same BE upon CE, right? So now if you see in the triangle, this is the triangle, O is here, this is perpendicular, this is a C, this is O, here it is a B and E, and this is a D. Half times OD times BE, this is the area of the triangle, and half times OD into CE, this is again the area of the triangle. So area of triangle we can write, this is area of triangle OBE, OBE upon area of triangle half times OD times CE, this CE. So this is area of triangle OCE, OCE. Okay. Now what is the area of triangle in other way around? I will tell you. This is our triangle, let's say ABC, and this angle, if you know, then area of triangle is half times AB times AC times sine A. Are you aware of this formula in trigonometry? If A is there, so you can write this side A, this side we can write C, and this side we can write B. If two included sides are given, if two sides, any of the two sides in a triangle are given, and included angle, let's say this side is given, this side is given, and this included angle is given, then we can get the area of triangle this way, half times AB times BC times sine of this angle. So the same thing we can apply in this triangle. So half times, this is OB times OE times sine of angle BOE, sine of angle BOE, sine of angle this BOE, and upon half times, now OC, now we are talking about this triangle, we are talking about this triangle OC. So OC, and then OE sine, and this angle we will be taking, this angle COE, sine of COE. Okay, so now OB is nothing but capital R, OC is nothing but capital R, they will get cancelled, half and half get cancelled, OE and OE get cancelled. So you are left with this and this get cancelled, OB and OC, though both are R. So in the next step, what we can write is here BE upon ECE is equal to OB is R times sine of angle this BOE. So what is BOE? If you see this angle BOE, this angle, so this angle is nothing but, this is the straight line, and this angle you have to find. This already you know 2C, and this one is pi minus 2C. Yes or no? So it would be pi minus 2C, pi minus 2C upon R times sine, and this angle COE, this is COE, this angle we are talking about. So this angle is nothing but, this angle is entire from here to here is 2B, and this much we have to find. So it is pi minus 2B. So it is pi minus 2B. So again R and R get cancelled. BE upon CE is equal to sine 180 minus theta, sine theta, so sine 2C, and sine pi minus 2B is again sine 2B. This is the relation we are able to establish. And what is this? Just see in the previous slide. As I told you, we have to take this side BC, and E is a point lying on this side. We have to find the coordinate of E. For this we need the relation, the ratio BE upon CE. If we are going to establish this relation BE upon CE, then we can easily get the coordinate of point E. So again drawing it here, This is B, this is C. The coordinate of B is x2 comma y2 and the coordinate of C is x3 comma y3. There is a point E here and E in such a way BE upon CE is equal to sine 2C upon sine 2. So it means that BE is sine 2C and CE is sine 2B. Yes or no? So the coordinates of E are, what are the coordinates of E? As I told you, this sine 2C will multiply in the section formula. We shall be using the section formula x3 and sine 2B, this will be multiplying with x2. So coordinate of E will be what? You can write this way. So x2 sine 2B plus x3 sine 2C upon sine 2B plus sine 2C. Is it clear? This is the abscissa, means x coordinate. Now we shall be doing the y coordinate also. So again sine 2C will be multiplying with y3 and sine 2B will be multiplying with the y2. So it would be y2 sine 2B plus y3 sine 2C upon sine 2B plus sine 2C. Yes or no? So now it is done. What we got? We got the coordinate of E. So now moving to the next slide. Now see it here. This is your point A in the triangle I am talking about. This is your point E. This is your point O. AO is already given, that is the circumradius. Coordinate of E just now we got in the previous slide. What is the coordinate of E? This is the coordinate of E. So if we got the coordinate of E and if we have to find the coordinates of O, so we just need the relation AO upon OE. What we need? The relation AO upon OE. This relation we have to establish, that's it. So now going to the previous slide, see in the triangle, we have to find AO upon OE. Okay. So for this, we are concerned with this angle. Why? Because in this angle, we are talking about this. This is 90 degree. So this is hypotenuse, perpendicular, just opposite to. I am talking about triangle ODE. See, ODE. OD. This is your D, this is E and this is O. This is making an angle of 90 degree. So this is your hypotenuse. OE is your hypotenuse. OD. OD if we are getting, then we can easily get the value by using this trigonometric relations. So how to get OD? OD we can get in this relation, in this triangle. So for OD, this is already R, yes or no? Triangle OBD. So let us see here. This is O, this is D and this is B. OB already you know R. We need OD. So how to get the OD? So this angle we will take. So sine B is nothing but OD upon OB. Yes or no? So OD is nothing but R. OD, sorry, this sine, let me rub this part here. Okay. See, this portion, let me rub it so that it will be easy for us to draw in a proper way. Now see, this is your triangle, this is B, this is O, and this is D. This is making an angle of 90 degree. OB is nothing but the circumradius R. We have to find BD. So how will we find, what is the relation we will take? This is your hypotenuse OB. BD is what? Base. So what do you need to take? Cos. Cos B is equal to BD upon OB. So BD is as it is because BD we have to find and OB is nothing but R. So therefore BD is equal to R cos B. BD is nothing but R cos B. So we got the relation BD. Now we talk about triangle ODE. So this is OD and here it is E. This is 90 degree. This is O, this is D, and this is E. Now see the slide previously. We got this BD. BD is nothing but R cos B. This we got it, R cos B. And here in this triangle, if we need to get OD, and the same can be applicable here also, like this we can use it. So just come to the previous slide. Here cos B, BD we got. What is OD? OD will be sine B is equal to OD upon OB. So it would be sine B is equal to OD is nothing but OD only and OB is R. So OD is equal to R sine B. OD is nothing but R sine B. So see here in this triangle OD is nothing but R sine B. So we are talking about this triangle wherein OD is given and we have to find DE in the triangle ODE. So let us see here. OD, what is OD? We got R sine B. So this is R sine B and this is 90 degree. This is the angle. We have to find this angle. What would be the angle, measure of this angle? So this angle is nothing but, this is the straight line. Yes. So it makes entire what, how much? 180 degree. Okay. Now, if you talk about from here to here, this one. So this is, this angle is, what is this angle? What is the measure of this angle? This is BOE. BOE is nothing but pi minus 2b that we got already. And this angle if you want to take in this, so from here to here, this is A. So A minus pi minus 2b. So this angle is nothing but A minus pi minus 2b. This angle is A minus pi minus 2b. So here if you put here minus, so it will be plus A minus pi plus 2b. So in triangle DOE, what is A minus pi minus 2 plus 2b? This can be written as A minus, what can you write in place of pi? 180, or you can also write A plus B plus C. Yes or no? Minus plus 2b. So it would be A minus B minus C plus 2B. Yes or no? So here what will you get? A and A get cancelled. So B and 2B, so we are getting B minus C. So this angle is nothing but B minus C. This angle is nothing but B minus C. So here if you take cos B minus C, that is nothing but OD upon this OD upon OE. And what is OD? OD just now we got it here. OD is R sin B. So you put here cos B minus C is equal to R sin B upon OE. So OE will be equal to R sin B upon cos B minus C. We got the relation OE is equal to R sin B upon cos B minus C. So this is the only relation we have to use it in the next slide to get the answer. So moving to the next slide, R sin B OE is equal to R sin B upon cos B minus C. Okay. So now you have to convert this and OA already you know that is A. So OA upon OE, that is equal to, OA is R basically, this is R. So R upon R sin B upon cos B minus C, and this R and R got cancelled. You are left with cos B minus C upon sin B. See here. Now do some changes here. Can you add here 2 sin A and cos B minus C over sin B? Can you write like this? 2 sin A sin B. I have written in numerator and denominator both 2 sin A, 2 sin A. What is 2 sin A, sin B? Sin 2A, correct. Sin A, what can we write for sin A? 2 sin A. Sin A can we write here sin B plus C? How? Because sin pi minus theta is equal to sin theta. Okay. So in place of A, can we write 180 minus B plus C? 180 minus B plus C. And here cos B minus C upon sin 2A. Just see this step. Did you understand this one? This step. Cos B minus C upon sin B. This is the result we get, OE upon OE. That's what we wanted. That is cos B minus C upon sin B. This is the end result. Now we have multiplied both numerator and denominator with 2 sin A. So 2 sin A sin B is sin 2A. 2 sin A, no, basically what we have to do is sin A, B minus C, sin B. It should be sin A somewhere. Let me check on the previous slide. 2 sin B, here sin B minus C. Okay. So sin B minus C, if you are taking here, A and A get cancelled, 2B. This is B and minus C. So B minus C, that's correct. Cos B minus C is R sin B. Okay. So here sin 2B plus sin 2C upon sine 2a. Here, this is the relation. Sine 2b plus sine 2c upon sine 2a. So now you see the previous slide, the very first that we did, this one, sine 2b plus sine 2c. So sine 2b plus sine 2c is coming in the numerator. Here sine 2b plus sine 2c comes in the numerator. So moving to the next slide, this is your A, the coordinate of A is x1 comma y1. This is your E, the coordinate is already we have written here. Let me write it one more time. What is the coordinate? This is the coordinate x2 sine 2b plus x3 sine 2c. So x2 sine 2b plus x3 sine 2c upon sine 2b plus sine 2c. This is the x coordinate. What is the y coordinate? y2 sine 2b plus y3 sine 2c upon sine 2b plus sine 2c. You can write also at the same time. And this is the coordinate O, this is R, and this relation we got was, sine 2b plus sine 2c, and this is sine 2a, that this is what we got it, sine 2a, this upon this. So if you multiply this one with this, what will you get? Tell me. This sine 2b and sine 2c will get cancelled. This is the numerator, this is the denominator. And this one you have to multiply with x1. So it would be x1, the coordinate of circumcenter O is x1 sine 2a plus x2 sine 2b plus x3 sine 2c upon sine 2a plus sine 2b plus sine 2c. This is the big theorem that I have proved. And then again y1, now you take y1 now, y coordinate, multiply this one with y coordinate. So sine 2b plus sine 2c and sine 2b plus sine 2c will get cancelled. So you are left with, here you will get y1 sine 2a plus y2 sine 2b plus y3 sine 2c upon sine 2a plus sine 2b plus sine 2c. Okay, so this is the entire result basically of circumcenter. How much did you understand? This is a bit beyond your level, of course, but even if you have understood 50%, this is more than enough for you, because in your exam I don't think they will ask you for these type of things. They are not asking, they are asking very straightforward question. So this session is for JEE especially. So here your main concentration should be like, what is orthocenter, what is circumcenter, what is incenter, what is centroid, then what is the formula also. So your end result is your goal. In a triangle, all the vertices x1, y1, x2, y2, x3, y3 are given, and all the angles are also given. Then you can get the circumcenter by using this formula. What is 2a, 2b and 2c? 2a and 2b and 2c are double of the angles of the triangle. So this is the very big theorem that we have proved it, and same conceptual clarity should be there with orthocenter also. Now in orthocenter, what will happen? Here, what is orthocenter? What is orthocenter? Sometime before I have explained it. Orthocenter is the point of concurrency of the altitudes. How many altitudes are there in a triangle? 3 altitudes. AD is an altitude. Now BE is an altitude and CF is an altitude. Is that correct? So all are making an angle of 90 degree with the opposite side, correct? Now tell me one thing, this point of concurrency H, this is known as orthocenter. You have to find the coordinate of this orthocenter if you are given the coordinates of the vertices x1, y1 of A, B, x2, comma, y2 and C is x3, comma, y3. Okay. Now tell me what would be the angle of this in triangle BCE. BCE, E is making an angle of 90 degree. So sum of this angle and C angle must be 90 degree, yes or no? So B, this portion, not complete B I am talking about, I am talking about this only. This will be 90 minus B, yes or no? 90 minus C basically. Why? Because this is making an angle of 90 degree. And which triangle we are talking about? We are talking about this triangle. In this triangle, sum of all the angles is 180 degree. One is already 90 degree. So this angle will be how much? 90 minus C. Yes or no? In a similar way, what would be the measure of this angle? Tell me. For this angle, what you have to take? CBF. 90 minus B. Very good. Now, what about this angle? 90 minus B. Very good. What about this angle? 90 minus C. Very good. What about this angle? 'Do it fast. What about this angle? We will take A, B, E. 90 minus A. What about this angle? 90 minus A. Very good. 90 minus A. Very good. Okay. Same logic we will apply here. What is the logic? That 2 points are given and the line segment BC is given here. This BC is given, this is BC, this is B and this is C. Okay. Coordinate of B is given x2, comma, y2 and the coordinate of C is given x2, x3, comma, y3. Yes or no? There is a point that is lying on this line, that is D. Is D is the bisector? No, D is just making an angle of 90 degree. If we somehow getting BD upon DC somehow, then will we be able to get the coordinate of C, D, yes or no? By which formula? Section formula. Section formula is what? Mx2 plus nx1 upon m plus n. This is the x coordinate abscissa and ordinate is m my2 plus n y1 upon m plus n. So what we have to do? We have to establish the relation. Now we are taking the triangle BDH and we are getting the value of DH. Again we will take the triangle CDH and we will get the value of DH. We will equate both the equations and we will get BD upon DC. Now see here. In triangle BHD, in triangle BDH, in triangle BDH, see BDH, which one is BDH? this one. We have to get the relation BD. So what would be BD? We can do one thing, tan, we can take tan, so it will be easy. We have to take relation tan within bracket 90 minus C is equal to, can we write here DH upon BD, yes or no? So what is tan 90 minus theta? Cot. So cot C is equal to DH upon BD, yes or no? So BD cross multiplication, or DH you can simply write DH is equal to BD times cot C. This is equation first. We got one relation, DH is equal to BD cot C. In a similar way, if you take in a triangle CDH, tan 90 minus B is equal to, tan 90 minus B is equal to DH upon CD, yes or no? Now tan 90 minus B is what? Cot B, and DH upon CD. So DH is equal to CD times cot B. Equation second. From equation first and equation second, both DH is equal to BD cot C and DH is equal to CD cot B. So can we write here BD cot C is equal to CD cot B? Can we write here? So what would be BD upon CD? Tell me fast. What would be BD upon CD? Cot B upon cot. Can we write here tan C upon tan B? Yes. What does this mean? This is BD upon CD. What is this? This is BD and this is CD. So what would be this much length? Tell me fast. BD upon CD is what? Tan C upon tan B. So can we write here tan C and this one is tan B? We got the ratio. So now what we need to do? We need to get the coordinate of D. So how will you get the coordinate of D? Sorry, how will it come? The same thing. Okay. Okay. Okay, now just remember this tan C and tan B. Tan C and tan B, and we can get it in the next slide. This is B, this is C. What is the coordinate of B? First, x2 comma y2. Very good. What is the coordinate of C? x3 comma y3. There is a point lying here, that is D. We have to find the coordinate of. We got the relation here just now, BD upon CD or DC is equal to what? Tan C upon tan B. Yes or no? So this is tan C and this is tan B. So the coordinate of, what would be the coordinate of? The coordinate of coordinates of D is, what is the coordinates of D? Do it fast. Keep the phone away. The coordinates of D. This will multiply to this. This will multiply to upon tan B plus tan C. Yes. So can we write here directly this side x2 tan B plus x3 tan C upon tan B plus tan C. This is the abscissa x coordinate. What is y coordinate? In a similar way, y2 tan B plus y3 tan C upon tan B plus tan C. Is that clear? So now see the triangle. What is the triangle? In this triangle, this is A, this point was D, there was a point somewhere, this is H, coordinate of A is given x1 comma y1, and coordinate of D we got, this is the coordinate of D. If we somehow get AH upon DH or HD, somehow we are getting same section formula we shall be using, and then we will get the coordinate of H. That is our purpose. And what is H? H is the orthocenter. So we are actually getting the coordinate of H. So now see in the slide, previous slide. Here we got HD. HD we got already. No, we got actually this BD upon DC we got. Now we have to find AH upon HD. For AH upon HD, we have to take the relation. This is firstly we need to get this value BD in triangle ABD. In triangle ABD, can you get BD? Yes. This is 90 degree, okay? This is hypotenuse. AB is hypotenuse. And BD is the thing that you have to take. And 90 minus B. So can you write here, this is P, sine 90 minus B is equal to BD upon AB. Can we write like this? In triangle ABD. In triangle ABD, can we write sine 90 minus B is equal to BD, this is BD perpendicular upon hypotenuse. So what is, okay, what is sine 90 minus theta? Cos B, yes, and BD is BD only, and in place of AB can you write here C, because AB, this side can be represented with a small c. So if you do the cross multiplication, you will get BD is C cos B. BD is nothing but C cos B. This, the length of BD is nothing but C cos B. Now in triangle DBH, in triangle DBH, this is C cos B. So we can get DH. So moving to the next slide. This is your D, this is your H, this is your B. What was BD? Was that C cos B? You can verify it. C cos B. And what is this angle 90 minus C? So this is 90 minus C. So we have to take the relation this and this. So what we can take? 10. Very good. So tan 90 minus C is equal to DH upon C cos B. Yes or no? BD. So this is cot C is equal to DH upon C cos B. So DH is equal to C cos B. This is cot, right? Tan 90 minus C is cot C. So C cos B cot C. This important result you have to learn. Now moving to the next. Here see, we need to get this length AF as well. So for AF, we will take the triangle CFA. Which triangle we will take? CFA. In this triangle, this angle is 90 minus A. So 90, this relation, this one and this one. So this is a P and this is a B. This is a perpendicular and this is making an angle of 90 degree, and AC is hypotenuse, so AC will be B, small b. So here it would be B cos A. AF will be B cos A. So B cos A. You have to take triangle AFH. Triangle, I will write this way, A, F and H. AF is equal to B cos A. This is the angle that you have to find. See it here. Did you understand how it became B cos A? We have to take in triangle, let me take in this triangle. We have to triangle ACF. In triangle ACF, ACF, in triangle ACF, you take simply sine 90 minus A is equal to AF upon AC. Yes or no? So cos A is equal to AF upon, in place of AC can we write here B, small b? In place of AC can we write small b? Yes. So this is a small b, the entire length of this AC is small b, so it would be B cos A. So it is B cos A. AF is B cos A. See, AF is B cos A. And what is the angle here? You can check the angle also. This angle is 90 minus B. This angle is 90 minus B. So let me delete this slide. This slide has nothing to do. Again. This slide is, this is 90 minus B. 90 minus B. Okay. We have to find AH. How will we get AH? Cos 90 minus B. So if you take cos 90 minus B, that would be AF upon AH, because this is making an angle of 90 degree. So cos 90 minus B, sin B is equal to AF is B cos A upon AH. So AH is nothing but B cos A sin B. AH is nothing but B cos A sin B. Is that clear to you? So what we got? We got AH. We also got DH. So this is A, this is D, this is H. Coordinate of A is x1 comma y1. Coordinate of D, what we got in the previous slide? x2 tan A tan B plus x3 tan C upon tan B plus tan C, and y2 tan B plus y3 tan C upon tan B plus tan C. So we got the coordinate of D. Whatever we are doing so far is to get the relation AH upon DH, right? So AH we already got, DH we already got. So what we have to find? AH upon DH first. So AH upon DH can be written as B cos A sin B upon C cos B cot C. Is that clear? So in the next slide, yeah, remember this, AH upon DH. So AH upon DH is equal to b cos a sin b, b cos a sin b upon c cos b, c cos b, and what is this cot c? So cot c, can you write it cos c upon sin c? So cos c will cos c will come here and sin c will come here. Is that clear to you? Yes. B cos A sin B sin C. B cos A sin B upon C cos A, B cot C. Cot C is cos B upon cos C upon sin. Sin will go up. Is this sin B? B cos A sin B upon C cos B cot C. Okay. Okay, moving to the next here. Now see here. B upon sin B is equal to C by sin C is equal to A by sin A. Are you aware of that? In trigonometry, A upon sin A is equal to B by sin B. So we can write here B sin C is equal to C sin B, right? Basically, if we transform it in the form of tan, because tan A is there, so this transformation will take into the form of tan B plus tan C upon tan A. Okay, this step we have to go. This is a trigonometric step basically. So if you transform this in the form of tan, it will be in the form of tan B plus tan C upon tan A. So the entire part would be A, B, and this is H. So this is H. So A is x1 comma y1. What was B? Tell me fast. What was D? D basically, D point here. x2 tan B plus x3 upon tan B plus tan C. Now x3, sorry, y3, y2 tan B plus y3 tan C upon tan B plus tan C. Yes or no? What is the ratio? Tell me. AH upon DH. So AH can be written as tan B plus tan C. Yes. And DH can be written as tan A. Now multiply. What will you do here? Get the section formula. In section formula, how will you do? This tan B plus tan C will be multiplied with this. Then tan B in the denominator, this and this will get cancelled. You are left with only x2 tan B plus x3 tan C. And if you multiply tan A, you have to multiply with x1. In the denominator, what will you write? Tan A plus tan B plus tan C. So, coordinates of what is this? Orthocenter, right? Coordinate of orthocenter is, what is coordinate of orthocenter? H within bracket x1 tan A plus x2 tan B plus x3 tan C upon tan A plus tan B plus tan c. In a similar way, if you take for y coordinate would be, here I am writing y1 tan a plus y2 tan b plus y3 tan c upon tan a plus tan b plus tan c. So it is just for you to understand this, otherwise this question will not come in exam. If they are asking you what is the, it is no plug and play, the questions will be given, formula you have to apply and you will get the answer. So this is the formula basically, so big formula. And then after already I have already proved it, the centroid and the circumcenter also. So I will just recapitulate. I am not going to prove, but I will tell you what is the formula for centroid and what is the formula for incenter. So A is x1 comma y1, B is x2 comma y2, and C is x3 comma y3. G is the centroid. G is centroid. So the coordinate of G would be x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. So this is very easy, and that's why everybody remembers this one. In a similar way, this is, I will write here centroid so it will not be confusing for you. And now if I am talking about incenter, A, B, C, so A is x1 comma y1, B is x2 comma y2, and C is x3 comma y3. This is your incenter I. Then the coordinate of incenter is ax1 plus bx2 plus cx3 upon a plus b plus c. Now ay1 plus by2 plus cy3 upon a plus b plus c, where a, b, c are the sides of the triangle and x1, y1, x2, y2 and x3, y3 are the vertices of the coordinates of the vertices of the triangle, right? So these two, orthocenter and circumcenter, was the most difficult one that we have just proved it. If you will see my video, then easily, I mean it takes only 1-2 steps and you will get it. But the logic is same. What is the logic? Logic is same. First of all, D is the midpoint, because we are talking about the median. What we are talking about? Median. So BD is equal to DC. What is the coordinate of D? Tell me fast. Because it is the midpoint, so ratio is 1:1. X2 plus X3 and Y2 plus. Okay, now this is the median AD. G is the centroid. G is the centroid. You have the got x1 comma y1, and here we got x2 plus x3 upon 2 comma y2 plus y3 upon 2. Yes or no? Only what you require is AG upon GD, this ratio. If we get this ratio, then we can again use the section formula and we will get it. So what is the way? See here, if G is here, so if you join this, what we are doing is this, we are joining this. So you know, and even if you don't join, you don't need to join at all. Why? Because AG upon GD is already given. What is that? 2:1. Did I tell you that centroid divides the median into 2:1 ratio? So GD upon DG is 2/1. Yes or no? So upper part is 2 and lower part is 1. Simply apply the formula and you will get it: x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. So getting the centroid is the most easiest among all the 4 concepts. Second easiest is this in center, because looking the formula itself you can say it is not a big formula. But when it comes ortho center, then what is the formula for ortho center? Recall it. X1 sin 2a plus x2 sin 2b plus x3 sin 2c upon sin 2a plus sin 2b plus sin 2c. And what is the y coordinate? Very good. Sin 2a plus y2 sin 2b plus y3 sin 2c sin 2b plus sin 2c. Very good. What is the coordinates of ortho center? A plus tan c. What is the y coordinate of ortho center? Yes. Plus tan c. Okay, so this is more than enough. You don't need to prove it. I have proved it so that you will get more clarity. Now I will talk about the simple slope. So slope is, I will simply prove it one very basic, it won't take much time. So this is the coordinate axis, okay? X, x dash, y, y dash. This is O origin 0, 0. Let's say 2 points are there, 2 lines are there. These 2 are lines, okay? This is for an example L and this is M. The slope of this is M1 and slope of this line is M2. This angle is theta 1 and this angle is theta 2. Clear? You have to find the angle between 2 lines. This angle, let it be theta. So using slope, find the angle between 2 straight lines. So we have to find the angle between 2 straight lines when the slopes of 2 straight lines are given and both are intersecting. Even if they are not intersecting, they must be parallel, because 2 lines are either intersecting or parallel. There is no third condition. In 2D plane, in 3D plane we have, like in 3D, if we have one line like this, another is like this, they are not parallel and they are not intersecting. So this, both the possibilities are there. But when it is one plane, like this is one plane, so both the lines will either intersect or they are parallel. So they are intersecting. So here, tell me one thing. Can you write here theta 2 is equal to theta plus theta 1? Basic trigonometric formula that if external angle is equal to sum of the 2 internal angles. Are you aware of this? This ABC is a triangle and this is up to D. So angle ACD is equal to angle A plus angle B. This is 10th class geometry. So this external theta 2 will be equal to sum of the internal theta plus theta 1. Okay. So next step is theta can be written as theta 1 or theta 2 minus theta 1. Yes or no? Theta can be written as, this will come this side, so theta 2 minus theta 1. So you have theta is equal to theta 2 minus theta 1. Theta 2 minus theta 1. So can you add both side tan? Yes. So tell me what is tan A minus B? The formula tan A minus B is tan A minus tan B upon 1 plus So tan theta is equal to tan theta 2 minus tan theta 1 upon 1 plus tan theta 2 tan theta 1. So tan theta is what? Angle between two lines, that is theta, and tangent of that theta. So tan theta is equal to, put tan theta 2. Tan theta 2, if you see in the slide here, theta 1 and theta 2 are the angles made in the anti-clockwise direction with the x-axis. So these angles are positive, and tan theta 1 is nothing but slope, that is m1, and tan theta 2 is nothing but the slope of this line m2, so it is m2. So m1 and m2 are the slopes, that is tan theta 1 and tan theta 2. So here, in place of tan theta 2, can we write m2 minus m1 upon 1 plus m1 m2 or m2 m1, whatever you want, you will write. So theta will be equal to tan inverse, it will come go that side, m2 minus m1 upon 1 plus m1 m2. This is nothing but angle between two straight lines. Now, if these two lines are parallel or perpendicular, so what will you find here? Tan. See, when these two lines are there and this theta intersect, so there are two possibilities. One is the extreme, like they are making an angle of 90 degree, and second one is there is no intersection, is 0 degree. So when theta is equal to 0 degree, then what will happen in this equation? Tan 0 is 0. So tan 0 degree is equal to 0. So in this, what will happen? I will write in the next slide. We have the formula tan theta is m2 minus m1 upon 1 plus m1 m2. So here tan theta is 0 degree. Tan theta is 0 basically. Tan theta is tan 0 degree, so it is equal to 0. So 0 equal to m2 minus m1 upon 1 plus m1 m2. Now do the cross multiplication. m2 minus m1 is equal to what? 0. So it will go that side, so m1 is equal to m2. And when tan theta will be 0? When it is parallel. These two lines are not intersecting, it means theta is equal to 0 degree. When the lines are perpendicular, they are making an angle of 90 degrees. So theta is equal to 90 degree. So here in this applied tan theta is equal to tan 90 degree, and that is nothing but infinitive. It can be written as 1 upon 0 also. So in this formula here, if you will apply 1 over 0 is equal to m2 minus m1 upon 1 plus m1 m2. So the cross multiplication, what will happen? 1 plus m1 m2 is equal to 0. So m1 m2 is equal to minus 1. Yes. So it means that when the lines are perpendicular, the slopes m1 m2 is equal to minus 1, and when the lines are parallel, then what will happen? Slopes are equal, m1 is equal to m2. So this is the basic that we have covered. Shall we continue or shall we? Begin and okay, then we will continue the next shifting of origin and transformation of axis in the next class. Thank you very much.